when we're setting up constraint problems, we're trying to find the maximum and minimum values. When you're given these specific constraints, it winds up being a type of problem where you have to sometimes identify which quadrant you might be in, or just a generic draw everything out and see what happens. Obviously, this was the first time you guys had to do these, and you probably recognized as you got going, the more space you gave yourself was probably a little bit easier for setting up your values. And that's kind of how it works, and that's great, and that's the idea as we go forward here. What I want to try and be able to knock out through this week is to dab our toes into the first couple of word problems today, and then go into them all tomorrow and Thursday, and then just quiz over all the stuff and be done with it Friday. Okay. That'll get us done, and then we can continue and then we can go into quadratics starting next week, which would be awesome. So as we look at this, the first two constraints that they give us gives us x greater than or equal to 0, y greater than or equal to 0, which means it's going to be first quadrant. So I'm just going to draw out first quadrant. And I know it's going this way and this way. And I'm done with those first two constraints. I go to the next one. Remember, a shortcut was cover and solve, cover and solve. When I'm looking at x plus y greater than or equal to 7, well, y-intercept of 7, x-intercept of 7. So we put them in. 7, 0, and 0, 7. Did that line go through the origin? No. What's 0 plus 0?
0.
Is 0 greater than 7?
No.
No. So it is false at the origin, which means it's shading outward. It's going this way. Are we okay with that? I do the same thing with the last constraint. The last constraint gives me a y-intercept of 10 and an x-intercept of 4. It intersected here. And then, again, is 0 plus 0 bigger than 20? No, so it's false, so I'm moving outward. So now the actual overlap area occurs in this problem. 1, 2, and 3. It overlaps everywhere out there. Everybody see that? Will there be a maximum on this problem? No. There's no lid on it. There's no maximum value. There's no lid. Okay, so there's no maximum. Now, the only other thing that we can do here is find out that ordered pair because we have to test for minimum. Okay. So we already have the two ordered pairs to test, the 0, 10 and the 7, 0, but we need to find this intersection. Well, the intersection there is where it's the solution set of those two equations. When you solve them as a system of equations, don't pay attention to the inequalities. It doesn't have any role in the problem anymore because all you're doing is trying to find where they run into each other. I think the easiest way to do this with this problem is to say that y equals 7 minus x by using direct substitution. You're okay with that? So when I do that, I get 5x plus 2 times the quantity 7 minus x is 20. So we get 5x plus 14 minus 2x is 20. Subtract 14, combine the two, we get 3x is 6, x is 2. So this ordered pair will be at 2, comma, well, 2 plus what is 7. So your ordered pairs to check. 0, 10, 2, 5, and 7, 0 into the constraint, the objective function of negative 2x plus y. So this gives me 0 plus 10, negative 4 plus 5, and negative 14 plus 0. minimum was at negative, excuse me, at 7, 0. That's it.
Yeah, I have just a question.
Yes, ma'am.
Under no max, why did you do like the 5x plus 2?
Oh, we were finding this. We were finding maximum and minimum. There's no maximum to this problem because there was no lid, but I still had to find this intersection point. The fact that it was no max was just I just wrote it there. That's all.
Isn't the
Good.
maximum 0, 10? Like,
There is no maximum because this is all going this way. There's no lid on it. There's no stopping it. So that when you're shading these things out, you'll start to realize, okay, there's no lid. I think we did an example the other day that had, oh, I hate when it does this. Remember this one had no bottom,
yeah.
so it had no minimum. So if there's nothing holding it
I
there,
thought that when you saw the points though, that like one was the maximum and one was the minimum.
not always. Not always.
Yeah.
There were some on here where like x was greater than 0 and y was greater than 0.
Mhm.
So would those intersect at 0, 0, so would you count that as a point in your shading?
If it wound up being, you know how we had one where it bound itself inward? I thought we had an example where it bounded itself in, where it might show up something like that. Yeah, then you would still count that 0, 0. Mhm. Yep. And that 0, 0 could wind up being the minimum.
Why isn't it the minimum in this case?
Because it wasn't shaded. In our region that we drew here, for the shading part, this
Oh.
wasn't, it's not in part of the shaded part.
Oh, okay.
Because if you look at, this stuff was going outward.
Yeah.
Okay. All right. You want to do one more out of the homework?
Yeah.
Which one?
20.
20? That's the one with the fraction in it.
No, it just has, it has 3.
Yeah.
Yeah. Excuse me. Okay. So we have first quadrant problem. I'm going to come back to this one and do that part last. X and Y intercepts at 2 and 4. Is 0 plus 0 bigger than 4? No, so it's false at the origin, moving outward again. 13 and 13 over 2 is what, 6.5? I know. I always say I hate decimals, but sometimes it's quick just to write 6.5. I probably should have scaled this a little bit differently. Let me do this real quick. Whatever. Is 0 plus 0 smaller than 13? Let's move it inward. Now the last one is the weird one. Negative x plus y is greater than or equal to 0. Isn't that the same thing as saying y equals x? So that's just going straight up, isn't it? Up 1 over 1. It's doing that.
Wait, how is that saying y equals x?
All I did is solve for y. Because if you look at it, yes, you have x, you have a 0, y-intercept at 0, x-intercept at 0, but if we put it in slope-intercept form, that's the equation y equals x, which means your y-intercept is 0 and you have a slope of 1. So from here, I know I'm going up 1 over 1, up 1 over 1 as I'm going through. So that means y equals x, but it also, if I go back here, it's y is greater than x. So is y greater than x?
To the left?
It's to the left, isn't it? So it's going in here. So now I have this region bound in this range, which gives me two spots I have to find where they intersect, here and here. Well, it just so happens that those two spots are relatively easy to find because you know that y equals x. And all I do is direct substitution, and you can get those ordered, two other ordered pairs. We're gonna see how that works?
Can we do it?
No. Joking. All right. So knowing that y equals x, if I'm going to find the intersection here with the 2x plus y is equal to 4, what I'm going to do then is 2x plus x is 4. 3x is 4. X is 4/3. So this ordered pair here will be at 4/3, comma 4/3. Okay. And I do the same thing with the other intersection point. 2x plus x is 13. 3x is 13. X is 13/3. Yeah.
So because y is equal to x, you just put x in there so you can solve x. And since they're the same, you just, okay,
Yep.
yeah.
And that's what's nice about this problem, that this line is an easy one to work with. If it was three of them where you were mixed together, you have to do your system of equations a little bit more. But since it's just kind of straightforward, slope of 1, y equals x, it's just plug and chug. It's real quick. And you get 13/3 for both of them. Oops. If you want to go get a drink, go ahead. You sound like you're dying. All right. So now you've got your 4 ordered pairs that you're going to test for your maximum and minimum in your objective function. And it's just direct substitution at that point. Do you want me to finish that out? It's just, you just multiply. 10 times 0 plus 3 times 4. 10 times 0 plus 3 times 13. 10 times 4/3 plus 3 times 4/3. You're just substituting in those these four values into the objective function. Which one gives you the biggest number? That's it.
How did you know the x equals y? I don't understand.
This part here.
Yeah, but it says it's greater than 0. So then
Remember when we're finding the intersection values here? When we're finding these points where they run into each other? I don't care about that anymore.
yeah.
I'm setting it as they're all equal, as just a regular system of equations. That's what I'm doing. The first part, when I plot them, then I'm worrying about all the shading versions of it. But when I try to find where they're running into each other, to the specific point, that's when I set up as an equation. Is that clear? That's a great question. Does that make sense, guys? Why I switch them from the shade versus the equal? Does that help clear that out a little bit? Pardon me. Do we name him Benny, I thought? Is that right? The fish, not him.
I was gonna say what?
Let me just call you Benny. Ben? Yes?
So what I was trying to do is put in 0 for x and 0 for y, and I don't know why I was trying to.
You did that right, because the idea is you're getting the x and the y intercept is going to go at 0, 0.
Yeah.
And that makes sense because the equation of the line is y equals x. So the idea is it's y equals 1x plus 0 is the equation in slope-intercept form, long form. Okay? Now, let me show you this. What I want to try here, so what do we got, 15 minutes? Or no, 20 minutes.
Yeah, we got it.
Okay. What I want to try and do is walk you through how you take the idea of an objective function and how you come up with it via the words. So instead of trying to have you guys write all this stuff down, I even 3-hole punched it. That's right. That's a big step for me. It really is. It really is. I tend to forget to press buttons on the machine, as you guys are well aware sometimes. I don't like to do that. This is also a rare thing. For this year, like I said, I've trying my best not to make copies, but this section, could you imagine the amount of time it would take to write down the problem? And then you would have no idea where that problem came from. So let's walk through how in the world how do you get to this stage by taking a whole bunch of words to come up with what are you trying to maximize, what are you trying to minimize, what are your constraints that you're coming up with off of the problem, okay? So if I'm looking at one like this, let me go. I thought I had the tab open. Too many tabs, I don't worry about it. Fly High Airlines sells business and tourist class airline seats for its charter flights. Blah, blah, blah. In order for a plane to be chartered, at least 5 business class must be sold and at least 9 tourist tickets must be sold. The plane does not hold more than 30 passengers. They make a profit of $40 for each business class and $45 profit for each tourist class ticket sold. In order for Fly High to maximize profits, how many tourist seats should they sell? What is the objective? What do they want you to do? What do they want you to maximize? Profit. They want you to maximize profit. So you're going to maximize profit, which is your objective. Your objective is to make as much money as possible selling plane seats. So this is where you come up with your objective formula. Okay, so I'm going to call that P for profit. I can call it C like it did in the book yesterday and all that as well. And now I have the idea is, how much profit do I make? Well, I make $40 on, what was it, business?
Yeah.
And I make $45 on tourist. That's my objective. My objective is to make that money. Okay? Can I have less than 0 seats of business class?
No.
Can I have less than 0 seats of tourist class?
No.
So that means this is going to be a first quadrant problem. See how that works? I know that I have to have more than, greater than, I can sell none of them, but I can't be less than 0. And I can have to do the same idea for the tourist seats. It also gave you a little bit of information about at least 5. Well, at least 5 means what's the fewest amount of seats you can sell? 5. So it's,
Plus 0? You mean plus 5 at the end?
well, you can write it. I always start with this, thinking the idea is that knowing that it has to be positive, okay? Because now there's other information that will supersede it in a second. Because now I know that it has to be greater than or equal to 5 for at least. And the same thing with the tourist seats. I have to sell at least 9? So now I know it has to be between 5 and 9. It has to be more than 5 seats of this one, more than 9 in the other. How many total tickets can you fly? 30. Can I have more than 30?
No.
Can I have less than 30?
Yes.
Yes. Can it include 30?
Yes.
So I know that my final bit of information was business seats plus tourist seats have to be less than or equal to 30. That's not terrible. It can get a little messy from time to time, but it's not awful. Now I have to draw it. And that's the easy part. Can I slide this up? Are we okay? So when I go to draw this out, we know it's got to be we know it has to be first quadrant. Is it okay if I call this business and this one tourist, just because of the alphabet, X and Y?
So there's no reason, you just kind of.
And it'll work either way as long as you're consistent with your label. Okay. I know that everything has to be moving outward because it's first quadrant. But I also knew that it has to be greater than or equal to 5. Bless you. I know that that point it has to be at 5, 0. I also know the other one would be at, what was it, 9? 0, 9 goes this way, and it's up here. So right now I'm in this cap area. I'm somewhere in this region. What's the ordered pair at which those two intersected? 5 and 9, because it's vertical at 5, horizontal at 9, gives me the ordered pair of 5, 9. And now I got to put in my last bit. The last bit gives me x and y, or x and y intercepts at 30. So my scaling is going to be a little messy, but if I just draw it here, I know it's going to have to go through that. Everybody okay with that? I know it has to go through that. Yeah?
You know, why wouldn't you like cover up like the B and then have that like the Y and X intercept B? Okay.
I did.
Yeah.
I did. I did that, so it's got to be at 30 and 30.
Okay. I was gonna say why didn't you?
I think I just said it, I just didn't cover it.
Yeah, no, it's fine.
Okay.
I get it.
So now I just have to find out where that line, that diagonal line goes in with the vertical and the horizontal. And that's really, bless you, really, really easy to find because you know what's the y value there? 9. What's the x value here? 5. So you're at something at 9 and 5 and something. Well, 5 plus what is 30? 9 plus what is 30? There you go. So you're at 5 and 25 and 21 and 9 to get those intersection points. All from the original problem. Your original shaded region area now is in this little triangle where we're trying to make our money. And I have to check those 3 ordered pairs to see which one of them gives me the most profit. What was it? 40B plus 45T. So we're checking it at 5, 25, 5, 9. I don't think I'll make much money there. And 21 and 9. Yes, ma'am.
Wait, so how you got 21 and 25 and you just plugged it into B plus C greater than 30?
Yeah. Oh, and remember, you treat it as equals because you're trying to find the intersection.
Yeah.
Yeah. Yep, that's all it is. Just like we did yesterday, but sometimes you had a little bit more algebra to do. In this case, we have vertical and horizontal lines, so they're really easy to work with. Okay. So now it's just a matter of multiplying things out. Excuse me. So that's what, 540s is what, 200? I don't know what 25 and 45 is, but I think I wrote it down. I think it's 1325 for this. This one's 1245. 200, 450 minus 45 is what? 405. That's 605? Is that right? Is it 605 with the 5 and 9? It's still multiplying in my head.
Yes, it's
Thank you. So where are you going to make your most money? 5 and 25. Sell more tourist seats. Ben?
Isn't that kind of like common sense though? Some more tourist seats. Like,
Well, it can be, but what if the numbers are closer? You just have to figure out how many of them do you have to sell. I mean, there's 21 of these. If I sell 21 of those, that's 21 times 40, and only 9 of those. It's close, but you do wind up making more money if you sell more tourist ones. Okay. Oh, what was the game? Not paper. Wasn't there a game not too long ago called Craft Dealer? It's like the lemonade. It's like the lemonade stand. You guys ever play the lemonade stand game where you have so many lemons and all that kind of stuff? Yeah, I think they also call it Craft Dealer, where you sell crack. I think it's the same game. Same premise. It's a lemonade stand. You have if you're whatever. If you have a lemonade, yeah, it's a crack stand. If you have a lemonade stand, you're starting with certain constraints. You have to buy so many of these, buy so many of that. At what point do you sell more at what price? If you, for every dollar increase of this, you lose a sale here. You do all that kind of stuff. So it's kind of the same premise. If I look at the next one, what's the next one? The dance theater. This one. The dance theater company will appear at the University of Georgia. How exciting! We should take a road trip. Drove through Georgia this summer. Traffic is awful. You think traffic is bad in Chicago? Drive through Atlanta. I don't know if any of you guys have ever driven to Florida. You have to drive through Atlanta. You don't want to drive through Atlanta. It's awful. It's like a 20-mile stretch that's just bumper to bumper. It's terrible. And no matter what time of day it is. Anyway, so we want, according to the school policy, no more than 2,000 general admission tickets can be sold, and no more than 4,000 student tickets can be sold. It costs 50 cents a ticket to advertise the dance company to students, because the student-run newspaper is cheap. And it costs $1 in advertising to the general public, because the regular newspaper is expensive. They need to cut the students a deal. The dance company has an advertising budget of $3,000 for the show. Find the maximum profit if the company can make if it charges $4 for a student and $7 for general admission. Then how many student tickets should they sell? So you want to maximize what? Profit again. So we want to maximize our profit. Well, we have, how much profit do you make on the student?
$4.
I'm doing the profit one. The student one you make $4 for a student. I hate using S, but sometimes you kind of have to. For a student, and you make $7 profit for general admission. Okay. Can you sell negative tickets?
No.
Nope. So what quadrant should we throw in? Yeah. It's our first quadrant probably. Yeah. Let's say no more than 2,000 student tickets. Oh, general admission, excuse me, and then 4,000 students. So our general admission has a cap on it at 2,000. So you can sell up to 2,000, but no more than 2,000. So it has to be less than or equal to 2,000 for general admission. There's a cap on students as well, not because they're wearing hats. I know that's awful. Thank you for the smirk. Was your weekend good?
What?
Was your weekend good?
It was great. How was yours?
Fantastic. And then you have one other constraint in terms of advertising budget. 50 cents per student. And you can spend up to and including and you see how this last little bit of information is going to give you your diagonal line to intercept these two vertical and horizontal lines. Is that you really believe me or you're just nodding politely?
No, I get it.
I will say one thing, a lot of times that I mess up with this problem, since I did student first, a lot of times I call that my X value, even though it comes later in the alphabet. So just be careful when you label your stuff and how you put these things through. If you want to put, everybody's okay that we know it's going to be first quadrant problem, right? Okay. Let's go with our G value, since it still comes first here, and our student stuff here. Which just remember then, as your ordered pairs are going to go G and S. See how they flip in the equation though, the way it was written? That's about as goofy as sometimes these things can get, because how you label your X's. Vertical line at 2,000, horizontal line at 4,000. 2,000 and 0. And they're moving inward. Excuse me. G-intercept of? G-intercept of? S-intercept of? Ah. Dividing by a half means you're multiplying by its reciprocal, 6,000. Very good. 3,000 here, and 6,000 here. Inward or outward? Is 0 plus 0 smaller than 3,000?
Yes.
Inward. So we have now in this case, let me move this up some. We now have 1, 2, 3, 4, 5 spots. Obviously, I'm not going to maximize anything if I'm not selling anything. So I could probably not worry about 0, 0. Okay. But I do need to find this ordered pair and this ordered pair. And just like the last problem, we know the X value for the one, and we know the Y value for the other. Remember, 2,000 is the G. So half of what is 2,000? 4,000. So this would be at 2,000. Wait. No, hold on. No, it's 2,000, 2,000. Excuse me. Yeah. I got ahead of myself. I subtracted 2,000 over. So half of, what's 3,000 minus 2,000?
1,000.
1,000. Half of what is 1,000? 2,000. Sorry, I accidentally said 2,000 twice. So there's that ordered pair. Put 4,000 in for S. What's half of 4,000?
2,000.
2,000 plus what is 3,000? 1,000.
But isn't G 2,000? Wouldn't it be half of 6,000 plus 2,000?
For which point? This one?
Yeah, because you said like if 6,000 is S, like and half of 6,000 plus what? But don't we already know that the 1G is 2,000?
For this point, the 1G is 2,000 because it's vertical here.
Oh,
At this,
right.
I'm at
Up there.
I'm at the
Yeah.
horizontal here now. Yes, ma'am.
How do you know that that's like half of that, or like, how do you?
I'm just substituting in quickly. I'm just saying that 0.5 times something plus 2,000
And you're
is
just
3,000.
You're just making that less than or equal to sign like an equal sign, right?
Yes.
Yeah.
And then I'm doing 0.5 times 4,000 plus something is 3,000. I'm just solving those two equations independently. That's it. That's all it is, because we knew that the X value for one of them was 2,000, we knew the Y value for that was 4,000. That's all it works out to be. What I'd like you guys to do is, which one's the next one? The next one is another airline one, an electronics one. Do those two. Do those two for tonight. We won't worry about the butter one yet.
Should we shade?
You don't have to shade, because what I want you to try and do is juice those arrows. Because if you use the arrows, it's a little bit less messy.
Yeah.
By all means, if you guys want to shade these things, go for it.
The arrows are the only thing.
Really?
Yeah.
Then shade. Yes, ma'am.
I think I was doing.
All right, let me stop this real quick.
Okay.